Yes, let us have a huge round of applause, my dear friends. Let us have a huge round of applause. Endowment Lecture Series 2022, 27 November. It's a third session. A request to Honorable Vice Chancellor, sir. A very good evening to one and all present here. It gives me immense pleasure to welcome you all on this occasion of 27th Endowment Lecture Series and Orientation Workshop 2022, a UNESCO Chair Program for the Culture of Peace. Our culture believes in Ano Bhadraha Kratavo Yantu Vishwataha, which means let the noble thoughts come to me from all directions of the universe. So which inspires us to accept new thoughts, to excel ourselves, to regenerate, and to grow in a vertical direction. Thus, I will say this endowment lecture series gives an opportunity to learn, listen from various stalwarts, experts from their respective domains. So as per our tradition, we are going to start our program with World Peace Prayer, which is unique, which does not represent any caste, creed, religion, and it is entirely for the peace and happiness of mankind. So may I now request to rise all on your seats and join World Peace Prayer. I request to the technical team to play World Peace Prayer.
प्रतिपाद्या जय जय स्वसंवेद्या आत्मरूपा देवातुषि गणेषु सकलार्थमतिप्रकाशो म्हणे निवृत्तिदासु अवधारि गोजी गुरुर्ब्रह्मा गुरुर्विष्णु गुरुर्देवो महेश्वरः गुरु साक्षात् परब्रह्मा तस्मै श्री गुरवे नमः। पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते। ॐ शान्ति शान्ति शान्तिः।
Thank you. संत कबीरांचं एक वचन आहे, गुरु गोविंद साथे खडा, गुरु गोविंद साथे खडा काके लागू पाव, बलिहारी गुरुजी आपण गोविंद दियो बताए. त्याचा अर्थ असा आहे, जर परमेश्वर आणि गुरु एकत्र आले तर पहिला नमस्कार कोणाला करावा? उत्तरही संत कबीरच देतात, बलिहारी गुरुजी आपण, माझी एवढी पात्रता कुठे? गुरु तुम्ही आहात, गुरु तुम्ही आहात, म्हणून परमेश्वर माझ्या दारी आलेला आहे. त्यामुळे पहिला नमस्कार जो आहे तो फक्त गुरुलाच राहील. सो आय वुड से गुरूंची जी मांदियाळी आहे, गुरुमूर्तींची जी मांदियाळी आहे ती आपण उभी करतो आहे या एंडोमेंट लेक्चर सिरीजच्या माध्यमातून. So we are getting blessed and we will have a growth in a vertical direction, and that is possible because of the eminent lecturers or experts who are coming here, expressing their thoughts, guiding us. So today we are blessed with Honorable Dr. Bhanu Pant, who is a former outstanding scientist, Group Director, Vikram Sarabhai Space Center, Indian Space Research Organization, Trivandrum. So may I now request Dr. Mandar Lele from MIT-WPU University to give introductory remarks and welcome speech. Over to you, Lele sir.
Thank you, Professor Mali. Dhyana Moolam Gurur Murtim Vidya Moolam Gurur Padam Moksha Moolam Guru Krupa. Ladies and gentlemen, very good evening to one and all. This is my immense pleasure to welcome one and all and introduce our today's speaker, Dr. Bhanu Pant. He is an outstanding scientist and group director from Vikram Sarabhai Space Center, ISRO, Trivandrum, as Professor Mali has already quoted. But recently I get the information that he's from Uttarakhand, and he is a stalwart from IIT Roorkee for BTech, PhD, and MTech from IIT Kanpur. He has worked more than 40 years, that is 4 decades. That 4th decade is, I'm quoting very specifically, for ISRO from 1982 to 2021. And that too for the various missions he has contributed, starting from Chandrayaan, MOM, Gaganyaan, SLV, PSLV, and so many so forth. For his incredible contribution, he has been awarded with lot many awards, starting with the National Council Award for the metals in 2021, ISRO Team Excellence Award for 2 times in 2012 and 2015, Metallurgist of the Year for 2012, and so many and so forth. The award list is so huge that I need at least 15 minutes to read that awards. He is having a lot of contribution for reduction of weight as well as cost for the spacecrafts, and he has a key scientist working in the metals and metallurgy for the various aspects for the spacecraft missions. He is having a unique group contribution for Gaganyaan, and he is having more than 100 papers. Even though he is in ISRO, he has written more than 100 papers, having more than 1,000 citations, and having 5 patents on his account. So let me welcome once again Dr. Bhanu Pant, none other than he is talking today on ISRO Today and Tomorrow. So with this, I would like to request Honorable Vishwanath Karar sir to facilitate our today's chief guest. So I will hand over mic to further processing to, Milind Pandey sir wants to talk something. Professor Milind Pandey sir.
My friends, today we have a great honor. We have with us Honorable Rahul Bhante Bodhi, who is our peace ambassador who represented Buddhism at our World Peace Conference many times. It's our great honor to welcome him, to receive him at this occasion. Start the function.
मित्र हो, 27th एंडोमेंट लेक्चर सिरीज योगायोग असा की आज 27 तारीख आहे, सेशन 3, and we are having a guest, Honorable Dr. Bhanu Pant. Bhanu means Surya, the sun, a constant source of energy. So we are blessed to have Dr. Bhanu Pant sir here as a speaker. So may I now request Honorable Dr. Bhanu Pant sir to speak his mind on this occasion. Over to you, sir.
So, very good evening to one and all. I am privileged and thankful to the organizers for inviting me here. And especially it was my privilege to meet Professor Karad today, which I didn't know really. Actually, I'll be meeting him today. So it's really a great honor. And I wish you very well actually in his so many vision actually I could get today from him. और मुझे बहुत अच्छा लगा कि आपने उत्तराखंड में भी हमारे बहुत अच्छा एक डेवलपमेंट किया है, जहाँ पे एक सरस्वती जी का बड़ा अच्छा मंदिर बनाया है, तो बहुत बहुत धन्यवाद उसके लिए। तो मैं आज इसरो के बारे में बात करने वाला हूँ, टुडे और एंड टुमारो, बेसिकली इट इज़ व्हाट वाज देन एंड व्हाट इज़ नाउ। मेरी जर्नी शुरू हुई एक्चुअली उत्तराखंड से। आई वाज बोर्न एंड ब्रॉट अप देयर एंड देन आई स्टडीड ऑल्सो देयर, एक्चुअली रुड़की इज़ ऑल्सो इन उत्तराखंड। वहाँ से फिर कैंपस से ही मैं चला गया था इधर इसरो में, त्रिवेंद्रम 1982 में। तो आई हैव नॉट सीन द वर्ल्ड, इफ़ यू सी फ्रॉम दैट एंगल, इफ़ यू लुक एट इट, आई हैव बीन देयर फॉर 39 years plus, as he said just now, Professor Mandar said. I thank him for his introduction also. So I have seen in my formative year, the formative years of ISRO basically. ISRO was evolving, and Dr. Kalam was at the helm at that time for the SLV program in a big way, and I had fortune to meet him and listen to him and learn from him few things. And of course, beginning was very humble. As you can see in this first my biograph here, you can see a small rocket going up in the left side, which is a sounding rocket which went in 1963. And basically it was so small rocket, but it was a big beginning, and the whole activity started from a church building. So Professor Karad sir, actually you will be appreciating that the whole ISRO program started from a church building basically. There was no building available, and this location was precious to Dr. Vikram Sarabhai and Dr. Homi Bhabha, who went there and then requested the local church to lend them a building for all kind of research and bring out the rocket program for India. So this was the very small beginning, but then from there we are today talking about Gaganyaan, which is shown in the below slide, just below that. And in the satellite area also, which we have today separate center. Although the program started from Trivandrum, the church building, धीरे धीरे जो है उसका रॉकेट डेवलपमेंट जो है वो त्रिवेंद्रम में होता रहा, और उसके बाद सैटेलाइट के लिए हमें बेंगलोर में एक सेंटर डेवलप हुआ, और एप्लीकेशन के लिए अहमदाबाद में, लॉन्चिंग के लिए चूँकि बड़े रॉकेट्स थे और बड़े मिशंस होने वाले थे तो श्रीहरिकोटा डेवलप किया गया बाद में। तो सैटेलाइट एरिया में अगर आप देखें तो शुरू में 1975 का एक छोटा सा रॉकेट यहाँ पे छोटा सा सैटेलाइट यहाँ पे दिखाया हुआ है, वो आर्यभट्ट सैटेलाइट था, करीब 450 किलोस ऑफ वेट starting from there, and then there was a communication satellite which went first, एप्पल प्रोग्राम था, वो एजुकेशन प्रोग्राम रिलेटेड था, जिसका एक बुलक गाड़ी पे बुलक कार्ट पे ले जाते हुए दिखाया गया है इस पिक्चर में. सो दैट वाज द ओल्ड टाइम्स एंड दैट इज़ हाउ द होल स्टोरी ऑफ ISRO started. And today we are talking about again satellites. If you take communication satellites, remote sensing satellites, science missions like Chandrayaan-1, which has caught imagination of the whole world basically, and it was a very successful mission. Chandrayaan-2, we had the mission for landing the rover on the moon basically, but then we had small hiccup there. We could not land it, but the orbiter is still working. I mean, I am happy to say that, and this is giving valuable science data of the moon surface even today. And not only that, beyond that, ISRO had gone on a shoestring budget, which is come in the media in a big way also, the Mars orbiter mission, which is about 546 lakh kilometers away from Earth. So you can imagine the kind of brute force of rocket which is required to carry the satellite or spacecraft there. And not only that, one needs a lot of understanding of the planetary forces. So ISRO is a team effort again, and any effort, any big effort is a team effort, which I can see even here. I had gone to some of the workshops here. I found the students working even on a Sunday. So I am really thrilled to see that also. And then that is how they are winning All India one rank in many of the tournaments, I came to know. So it is very happy note actually to see that. So from such another view graph I have put here just to show that then and now. Here if you look, the space, whatever goes to space, actually that is carried in a payload fairing. First one is on a cycle, you can see that it is in 63. From Church Building they are carrying the payload on a cycle for the launch to the Thumba beach, where the launch pad is. Even today launches happen, sounding rockets from there. And in fact last week, I mean, we had different kind of programs. RH-200 is one specific type of sounding rocket, which 200th successful flight was, consecutive flight was there even last week. And there was a huge program. Mr. Kovind was there, actually our previous president. He happened to be available there. I mean, he witnessed the launch. And today, if you look at the GSLV Mark III, the largest rocket, which is carrying all satellites, communication satellites of the order of 4-ton class, with huge number of transponders into space, and which carried the Chandrayaan, which carried the Mangalyaan, which is going to carry many of our interplanetary missions. So this is and here if you see the payload fairing, this has to be carried in a truck, and you can see the size of that, sheer size of that. And this is not the size, dimension alone is not the point here. If you look at, इसमें बहुत सारी तकनीक भी उसी तरह से काफ़ी आगे बढ़ी हैं, चाहे वो कोई भी ब्रांच हो. मैं तो मटेरियल्स और मेटलर्जी का आदमी हूँ, तो हमने उस एरिया में काम किया. लेकिन जो बाकी आप देखिए, इलेक्ट्रिकल, इलेक्ट्रॉनिक्स, कम्युनिकेशन और मैथमेटिक्स, अप्लाइड मैथमेटिक्स, हमारे यहाँ बहुत अच्छा काम वहाँ पे होता था. तो सभी लोग मिल कर के जो है वो इस लेवल तक उसको लेकर आए हैं आज जो प्रोग्राम को. उसी में एक चीज़ और मैं कहना चाहूँगा, उस समय पे विक्रम साराभाई जी ने क्या कहा था कि यूज ऑफ स्पेस टेक्नोलॉजी शुड बी एज एन इंस्ट्रूमेंट फॉर द सोशो इकोनॉमिक डेवलपमेंट ऑफ द पीपल. So, in fact, Professor Karar was just mentioning about Professor Sarabhai. So, you can imagine that at that time when we were having small experiments which are carried on a bicycle and which are only in upper atmosphere of Earth, and it is science experiments for measuring wind velocity, its temperature, tide, etc. For the space physics laboratory people, or even UN had some program on that, but that was all very small scale. At that time he could envision that this is going to give us advantage in terms of public good. So that is the vision. Vision was same at that time, and vision remains the same even today. And this vision has been in fact brought to fruition over the years in a big way. As you know, our remote sensing satellites are giving data for crop management, land management, even ocean. Yesterday there was a launch of a satellite from PSLV, OceanSat, which gives huge data on oceans. Even fisheries department utilizes the data from the satellite that is there. And it is opening many new vistas, which I'll just cover in a brief way in my talk today. As I come to my outline today, here basically I'll just say few things about materials, and I'll touch upon other areas like workhorse launch vehicles. Then what are the preparatory technologies जो तैयारी करी है, जैसे गगनयान के लिए ही है, या फिर आगे आने वाले जो लैंडिंग एक्सपेरिमेंट्स हैं, मतलब आपका जो स्पेस शटल की तरह से जो रॉकेट जाएगा और उसमें आदमी जाएगा और वापस आएगा, उसके लिए कुछ जो तैयारी है वो थोड़ा सा मैंने इसमें एक दो छोटे वीडियो भी हैं वो भी मैं दिखाना चाहूँगा। और एक नया बहुत इंटरेस्टिंग एरिया आया है अभी माइक्रोग्रेविटी का, जिसमें बहुत सारे मटेरियल डेवलपमेंट हो सकते हैं नए, और बायोलॉजी के कई सारी रिक्वायरमेंट्स हैं उसमें। माइक्रोग्रेविटी जो है वो एक नया अच्छा एरिया है जिसमें रिसर्चर्स काम कर सकते हैं। So that also I have covered, I have touched basically. I cannot do justice today for in this talk for going deeper into that, but then I have covered that which are the methods by which this microgravity can be achieved, especially in Indian context. And sounding rockets are one of them, and our own PSLV it has been made into a orbiting platform for the 4th stage, which was going waste. So that also I will just show some features there, and then little bit of spacecrafts. Then totally new area has come of small satellites and nano satellites, which I think this campus is not unfamiliar. It is familiar with the concept, I am sure about it, which is the talk of the country or talk of the internationally. It is the important part of it today. And then few takeaways, what I could think, I have just put it here in my talk next. So materials basically क्यों ज़रूरी होते हैं, उसमें क्या है कि आपका वो जो है वो अलग अलग एनवायरनमेंट्स में काम करते हैं। स्पेस में जब जाते हैं तो कहीं पे बहुत कम टेम्परेचर है या कहीं पे बहुत हाई टेम्परेचर है, तो अगर वहाँ पे गलत मटेरियल आप यूज़ करेंगे तो वो पूरा फेलियर हो जाएगा। और दूसरा क्या है कि अगर ऑप्टिमाइज नहीं है तो आपकी जो कॉस्ट ऑफ लॉन्च है वो बहुत ज़्यादा हो जाएगी, तो वो भी इम्पॉर्टेंट है। तो जो आज की तारीख में जो रॉकेट्स हैं उनमें स्टेज को हम लोग गिरा देते हैं और वो बेकार जाती हैं। तो उनमें जो हम अभी 1 किलो को अगर हम सैटेलाइट को अगर छोड़ना है तो उसके लिए $25,000 वी स्पेंट टुडे, बट देन दैट कॉस्ट हैज़ टू कम डाउन, एंड दैट विल कम डाउन बाई around $10,000 और इवन लेसर बाई यूजिंग ऑफ रीयूजेबिलिटी कॉन्सेप्ट। रीयूजेबिलिटी तो अभी सभी चीज़ में आ रहा है, सस्टेनेबिलिटी के लिए भी बहुत ज़रूरी है, तो रॉकेट्स में भी रीयूजेबिलिटी का कॉन्सेप्ट बहुत इंपॉर्टेंट है, उसकी दिशा में भी काफ़ी काम चल रहे हैं अभी। तो और इसमें जो है मटेरियल्स का बड़ा भारी रोल है, क्योंकि मैं मटेरियल से हूँ तो थोड़ा सा मेरा बायस रहता ही है उसके लिए। उसमें हाई टेम्परेचर मटेरियल्स आपने देखा होगा, कल्पना चावला जो हमारी जिनकी मृत्यु हो गई थी उसमें स्पेस शटल के एक्सीडेंट में, वो स्पेस शटल का जो टाइल था वो फेल हो गया था, तो इट्स अ मटेरियल प्रॉब्लम। तो जो थर्मल प्रोटेक्शन सिस्टम है वो बहुत क्रिटिकल है, तो उस पर बहुत काम की ज़रूरत है। और उसमें जो है हमारे रिसर्चर्स सभी जगह, एकेडमिक हो चाहे इसरो में हो चाहे कहीं और इंस्टीट्यूट्स हैं, वहाँ पर भी वो काम चल रहा है अभी आप ये देखिएगा कि जो मैं वेट की बात कर रहा था, जो मटेरियल का जो सैटेलाइट को जो हम ले जाना चाहते हैं, वो हम सबसे भारी सैटेलाइट को कम से कम रॉकेट के वेट के साथ ले जाना चाहते हैं। और उसमें जो है ये एक पैरामीटर होती है जो पेलोड सेंसिटिविटी है। So weight saving, if I do for a particular stage by improving the material or by improving the system, how it can give advantage on the payload or satellite. So to get 1 kg of satellite advantage, improvement in the satellite weight, I have to save 150 kilos. You can see the ratio here. First one, PSLV, strap on, I have to change up to 150 kilos. So it is not very easy task. But then the moment you go to GSLV Mark III, which is highly optimized vehicle, and that is our latest offering for space launches, you can see that 25 kilos is itself will give 1 kg weight gain, and 1 kg weight gain means around $10,000 in terms of transponders. So it's a very huge advantage. And similarly, if you keep on going up means upper stages, first stage, second stage, in GSLV Mark III only 2 stages. So that is highly optimized vehicle. So you have 2 stages alone will do the job. And then upper stage में ही अगर आप 1 किलो satellite बचाएंगे तो वो same 1 किलो का आप extra transponders use कर सकते हैं. So any technology or any system will improve the weight of the satellite without reducing the performance will be of great advantage for the launches. Now I'll just come to PSLV and GSLV Mark III. I thought I'll just put the materials since some of you may be from materials background here. So you can see here the rocket basically is consisting of various materials in different stages. Strap-ons are normally made of a steel. Again, booster is made of a steel, special steel, which is a very high strength and high toughness material, which is essential because it requires a very high strength and very high toughness material. But then as you go up the stages, you need lighter materials because density of the material has to be lower. So steel density is around 8 gram per cc. But then you cannot afford to put the same material, although it is a high strength and high toughness, but strength to density ratio is not good. So then you have to go for lighter materials in the upper stages. So aluminum 2.7 gram per cc or titanium 4.5 gram cc kind of materials you have to use in the upper stages. Similarly for Mark III I have put it here. I will not spend much time because Professor Chitnis has given me some time. Mostly I'll try to stick to that and I'll take some questions after that. So this is GSLV Mark III. Here again a few special materials have been developed. In fact, Professor Mandar, I was mentioning about one material specifically. Here you can see one titanium 5Al 2.5 ELI. This was one thing which could make this rocket possible. If I don't brag, I mean that can be the one point which is coming here, because this has given around 100 kilos of satellite weight advantage. So 100 into $10,000. Each launch you are getting that kind of gain, and that many more transponders you can put, or you can carry that much heavy more payload for our interplanetary or science missions, because Mark III is used for all kind of missions. So this is what is the importance or power of the materials basically. And now I'll just come for the spacecrafts, what kind of materials are used and then how that is limited. जो भी सैटेलाइट में मटेरियल रहता है उसको स्पेस का एनवायरनमेंट देखना पड़ता है. उसमें रेडिएशन है और थर्मल साइकिलिंग होती है. बहुत कम टेम्परेचर है कहीं पे, कहीं बहुत ज़्यादा टेम्परेचर आता है, डिपेंडिंग ऑन द उसका जो सन के सामने है कि नहीं है. और दूसरा आपका एटॉमिक ऑक्सीजन है जो डैमेज करती है मटेरियल्स को. उसके बाद इवापोरेशन और सब्लिमेशन होता है क्योंकि वैक्यूम बहुत ज़्यादा है. और जो है फ्रिक्शनलेस एटमॉस्फेयर में दो मटेरियल जुड़ जाते हैं जो अच्छी फिनिश के रहते हैं, तो देन दैट विल नॉट, द सिस्टम विल नॉट वर्क एंड सब जीरो कंडीशंस आर देयर. And then there are certain particles which are debris that can hit the material, satellite and affect the performance. So you need to avoid certain materials which are having higher vapor pressure. Not only that, you have to coat certain if you have to use some similar materials, you have to coat them to avoid any sublimation. और उसके बाद कोल्ड वेल्डिंग के लिए उसको कोटिंग करके यूज़ करना पड़ेगा. स्पेशल कोटिंग्स हैं, मोलिब्डेनम डाइसिल्साइड वगैरह. और जो क्रायोजेनिक जहाँ पे उसका जो एक्सपोजर है, जहाँ पे ब्रिटलनेस आ सकती है, वहाँ के मटेरियल सिलेक्शन जो है बहुत क्रिटिकल है. उसमें फेस सेंटर्ड क्यूबिक मटेरियल्स होते हैं. मटेरियल साइंस और मटेरियल इंजीनियरिंग वाले लोग अच्छे से जानते हैं उस चीज़ को. तो जो ये बहुत इंपॉर्टेंट है स्पेस क्राफ्ट्स के लिए. तो ये जो है ये अलग क्राइटेरिया आ जाता है. और वेट टू डेंसिटी रेशो जो है वो तो है ही, मतलब स्ट्रेंथ टू डेंसिटी रेशो वो तो रहता ही है, पर लेकिन ये एडिशनल रिक्वायरमेंट्स हैं. अभी ये देखिएगा इसमें जो मटेरियल्स और मेटलर्जिस्ट क्या करता है. और दूसरा मैंने एक रॉकेट के साथ यहाँ पे कई सारे एरियाज़ डाले हैं जो कि चूँकि आप लोग अलग अलग इंजीनियरिंग बैकग्राउंड के होंगे जो यहाँ पे इवन फैकल्टी हैं या फिर जो स्टूडेंट्स भी शायद हैं, तो उसमें देखिएगा कि आप जैसे एरोडायनेमिक्स है, स्ट्रक्चरल डिज़ाइन वगैरह में जो है रॉकेट का पहले होगा, मिशन प्लानिंग होगी उसकी, या जो उसमें मटेरियल्स केमिकल्स यूज़ होने वाले हैं उसका पूरा एक डेवलपमेंट और स्ट्रेटजी पूरा बनेगा, और कौन सा मटेरियल कहाँ पे क्या लगने वाला है. और उसके बाद फैब्रिकेशन बहुत इंपॉर्टेंट है. मैन्युफैक्चरिंग टेक्नोलॉजी, मैकेनिकल इंजीनियर्स, आई नो वेरी गुड मैकेनिकल इंजीनियर्स आर देयर इन दिस इंस्टीट्यूट. सो उसमें जो उनका फैब्रिकेशन है, क्योंकि स्पेशल मटेरियल्स हैं आपके, जैसे आप टाइटेनियम अलॉयज़, मराजिंग स्टील, एल्यूमिनियम अलॉयज़, स्पेशल अलॉयज़, एल्यूमिनियम अलॉयज़, इवन सिरामिक्स आर यूज्ड. and other polymer-based materials, composites. There is a big gamut of materials which are used. So manufacturing technology also plays a very important part. Then propulsion systems are there, avionics, software, mission simulations. Each and every area actually is important. And with all this, and many things happen with the support of industry, even though planning is done by ISRO, but then the whole thing is done even at industry, or even support by the academics. So this is a combination of efforts from all people, including ISRO people and academic and industry, and then huge rockets are built up and then launched, which you see very often. And each launch is a separate new launch, basically new component, because we cannot say that we have launched once, so next time also it will work. It's not possible. So it is a very specialized and very high risk field. So anytime anything can happen in the rocket or satellite or anything, which you see once in a while. Rarely you see nowadays, but in the beginning of the time we had a lot of failures. So I have seen failures during my beginning years. ASLV, we had many failures, in fact, if I recall. But then people get that strength. As sir was telling, that spiritualism is very important. So I think there must be some strength from inside which comes, and then people fight back and then make it happen again. And then in materials area, we have lab to launch philosophy. We do first in the lab the material developments and process developments, and then take it to the industry for the larger components that is made. And there are variety of materials which I have listed here. And then programmatically you have to support. Suppose when the components have to be made, physically you have to take it to the full level, qualification level and system level, make it usable in the system, and then fly the rocket there. And quality control also, materials people are contributing big way, because without quality control it doesn't work, because non-destructive testing or many other methods are there, even to qualify, and to get the component reliably. And what are the drivers for our material selection? I thought I'll give few slides on materials in the beginning, and then I'll go to very general. And here if you see, main is the mission need. Whatever mission needs, suppose it is a Gaganyaan, then Gaganyaan based systems and materials you have to select, and then plan the activity according to that. And then many a time you try to improve the payloads, or you want to go for higher reliability, and because your non-destructive testing is limited, so you have to plan accordingly, the systems. So that is another thing. For manned missions, I was telling, huge reliability is required. So whole rocket itself has to be done man rating. So that is a separate work, and which is happening in a big way for GSLV Mark III program right now. And then second one is, earlier we had almost everything imported. अभी जो है उसको indigenous production सबका होता है, तो वो भी एक driving force है. और cost aspect जो मैं आपको पहले भी बता रहा था, तो cost aspect is another very critical and important. So there are processing methods, new processing methods, or even material selection one can have in that sense. And if you improve the performance of the same material by using certain new techniques, then it is again one of the driving force. And then coming to material issues, because always when you work, there can be some failures. So that needs to be understood very well. In fact, I recall one GSLV flight in the launch pad. In fact, it was not visibly there, but then one of the engineers, he noticed something dripping. The propellant was dripping, and it was a liquid propellant, which was some drops were coming. So he alerted the mission control. It was about to be launched, in fact. So then finally it was studied, and it was a very major issue. It has come up. There is something called stress corrosion cracking. Those in the materials and metallurgy background will know. And then launch was called off, and then we removed the stage, studied it in more detail, and then suggested the solution, then how to make the next time, same rocket went again with a new stage with improved process. So that was the one incident where it was in the last stage. But usually it doesn't happen. Usually you catch the problem much earlier. But this is what happened in one case. And this is one summary of the things, whatever has happened over the years. different structural materials, functional materials, then high temperature materials were developed. And futuristic basically is our re-entry is a big issue, as I was telling earlier also. So ultra high temperature ceramics is one of the development need of tomorrow, which people are working based on many zirconium, hafnium, diborides and composites of them. So that is also happening now. And then similarly high temperature, I have put another slide here because it was in my mind all the time. So here if you look, today we have solid motors, so ablatives are used in the nozzle area, and liquid and cryogenic engine, they have their own way of managing the heat. Thrust chamber area you have as high as 2000 degree temperature. So you basically, you can have either the cooling channels on the outside, but cryogenic needs more optimized systems. So there you have regeneratively cooled system, जिसमें liquid hydrogen जो जलने वाला है वो पहले वो chamber को cool करके फिर अंदर जलने जाता है, तो उससे उसके burning efficiency also goes up. So we have such kind of cryogenic engines today. So that is giving again advantage for our GSLV Mark III type of program or GSLV programs. Of course, GSLV was a cryogenic from Russia, and that created lot of ruckus at one point, which we are not getting technology and all that. But that was a very good lesson for ISRO actually. That made ISRO do a bigger cryogenic engine our own later. And then future, if you look, as I was telling, that leading edges, if they take the brunt of the heat, then other part of the rocket will be, in a safer condition. So that is a concept which is coming up for future applications. You can see the right side graph. If you look at the red color heat flux curve, with the your position in the rocket, if you look, there is a sharp decrease in the heat flux. So such vehicles are good in the sense your overall other areas of the rocket will be safe, but you have to protect only the tips. But you need special high temperature, ultra high temperature ceramics and some materials. That's where the work is progressing. Now I'll just show some of the technologies which has happened. Here one I wanted to mention which is of interest, general interest. Each one has a specific advantage or special, like first one is a explosive bonding we have used for joining of two special alloys, two aluminum 2219 and stainless steel of 321 grade. They needed to be joined without any helium, without any leak. So such adapters were made by explosive bonding, and it was qualified for cryogenic. It is flying. And similarly, when you look at silica tiles, which are seen here, that technology is there for the RLV program, reusable launch vehicle program, which has also been tested. Then you have Chandrayaan-2 itself. We have put up some our to protect the spacecraft. Multi-layer insulation is required, where one very special material, super light and super insulator, silica aerogel, that was developed, and then that sheets are used part of the multi-layer insulation. You can see one picture here. You can see a flower sitting over the material, and below that there is a Bunsen burner, and it is protected. There is no harm happening to the flower. So that kind of insulation this gives, and this material can be highly useful for even our defense applications. The soldiers in very low temperature regions, if this is used in the jacket as one layer, this can give a very good advantage. So this idea is there. Probably it may happen at some point of time. And these are some of the other initiatives. I think I'll not go into this material initiatives, and but they are all important for the space program today, tomorrow's. And one metal I wanted to talk, because that was where I started my career when I joined in 80s. That is titanium. Here basically you can see that 1982 when we started, we had one alloy and the size was around 200 millimeter diameter kind of gas bottles we were handling. और उसके बाद आज जो है वो 6 alloy हम लोग यूज़ कर रहे हैं, और उसका एनवायरनमेंट जो है रूम टेम्परेचर था पहले खाली, अभी उसको हम लिक्विड ऑक्सीजन टेम्परेचर में और लिक्विड हाइड्रोजन के अंदर वो कंपोनेंट यूज होता है, हाई प्रेशर. तो ऐसे कंपोनेंट इसमें डेवलप हो गए हैं, और इम्पेलर्स हैं, और तरह तरह के इसमें पार्ट्स आ गए हैं. तो ये एक मेटल की कहानी है, लेकिन इस तरह से तो वहाँ कई मटेरियल्स हैं. तो दिस इज जस्ट वन पार्ट. आई थॉट आई जस्ट शो इट. Now I'll go briefly to workhorse our rockets. 3 rockets are there mainly. Here if you, I wanted to mention basically you have rockets with different stages. Stages means basically you don't go with single stage, so you have to stage it because you don't have optimized materials and optimized thermal protection. So you have to go for staging, first stage, second stage, third stage, as I was showing in the first slide I had shown, the payload ratio. So here we talk of different type of propulsion systems for different stages. And we were held up for cryogenic stage at some point, which you all are aware. Russia, we had lot of difficulties. So why that was important? So I thought I'll just put one comparison of this particular thing is a simple thing basically. Each stage gives delta V, that means increase in velocity. To put a satellite in orbit, you need to accelerate it to by speed of 8.2 kilometer per second. So to achieve that, you have to accelerate in each stage gradually and then take it to that. So delta V is directly related to the specific impulse of the type of propulsion. So you can see here solid, which is used, solid motors are used all the time in the beginning, which we have mastery. They are very good for boosters to start the program. Sorry. To start the launch. But then beyond that, आपको जो है liquid या फिर cryogenic engine use करने पड़ते हैं. तो इसी के लिए जो cryogenic की importance आती है, जब आप 2 टन या 4 टन के सैटेलाइट जियोसिंक्रोनस ऑर्बिट में डालना चाहते हैं, तो आपको cryogenic engine यूज़ करना पड़ेगा. Sorry. So you can see the data here. Another new one engine is coming is semi-cryogenic, which is having 454 seconds of impulse, specific impulse. This will give our interplanetary missions booster. So I think I'll go to the next slide. So here you can see the configurations now. We started with PSLV, which was having solid S139 tons of solid propellant in the first stage, which is surrounded by 6 9-ton solid boosters, solid strap-ons. Then you have liquid 40 tons, and then you have solid again 3 tons, and then you have liquid. So there was no cryogenic. So we have limited capability up to polar and sun synchronous orbits, which I will be showing at some point. And then we went for the cryogenic stage, and then 2 tons of satellite we could take to the geo transfer orbit, which is communication satellites. And here we have liquid stage in the beginning, L40s, 40-ton propellant. There are 4 of them, strap-ons, and then solid stage of 125 ton is in the core, and then you have again liquid stage, and finally the cryogenic stage 12 tons, which was a Russian origin, that gave 2 tons of capability for geo transfer orbit or communication satellites. But this we could improve it, as I was telling. We could develop a 25-ton cryogenic engine for GSLV Mark III program, and then solid also we have gone for 200 tons, much bigger. Asia's, I think, or world's one of the highest capacity solid propellant motors, which are the strap-ons basically here. 2 strap-ons are used, and booster basically is liquid, which is 110 tons. It is a cluster of 40-ton engines. So this today gives the heaviest launch of 4 tons into geo transfer orbit. So this has the capability today. And coming to our satellites, I thought I'll just put together all the different kind of developments which have happened in the beginning. Some are experimental in the to start with. Then coming, there are operational phase. So in the launch vehicle, I already mentioned to you the many things, but I will say about satellites. When you look here, you had experimental Bhaskara 1 in the 70s. Today we have reset series we are talking about, INSAT, GSAT, all satellites are there. And here you can see one parameter, resolution. When you look at Earth, what kind of resolution you can get. So 1 kilometer was the resolution at that time, but today we are talking about 0.28, that means 280 meters basically. 0.28 meters. It is so fine resolution we are able to get, and we are able to put much higher payloads. So we can study much more about the Earth, and that data is even commercially utilized or even programmatically utilized by the government. And even taluk offices, I think they have now satellite data which are used for crop management and other groundwater and other activities. This is not my area, but then this is worth mentioning here. And then similarly, in the communication satellites, we had Aryabhatta to start with experimental phase, and now we have come to that is of course the science mission. Now we have come to Chandrayaan and Mangalyaan, which I was telling. And in case of our transponders, if you look, we started with Apple experiment, which you saw on the bullock cart. Today we have 282 transponders we are talking about in a satellite. So this is the journey which has happened over the years in ISRO. And this is just a similar thing, but then here I have mentioned certain materials. I think I'll skip this because materials may be not of interest to everyone. So I'll just skip this slide, but this gives the journey and associated materials, specific materials which were required and some specific technologies. And Abraham Lincoln has once said actually, if I had 6 hours to chop down a tree, I would spend the first 4 hours sharpening the axe. So this is very true for ISRO actually. ISRO में कोई भी काम मेजर मिशन होने से पहले उसको अलग अलग भागों में बांट के उसकी अलग अलग चीज़ों की तैयारी बहुत ज़ोर से की जाती है, और तभी उसमें मिशन को फिर लिया जाता है. जैसे आज हम गगनयान की बात कर रहे हैं, लेकिन गगनयान का जो बैकग्राउंड काम था या जो भी एक्टिविटीज़ थी वो बहुत पहले शुरू हो चुकी हैं. और उसके अलावा जैसे कल को हम जैसे रियूजेबल लॉन्च व्हीकल है दूसरा, जिसको हम लैंड करना चाहते हैं, जैसे विंग के साथ, उसका भी काम पहले ही शुरू हो चुका है और उसके कई एक्सपेरिमेंट्स होते रहते हैं. वो मैं जस्ट थोड़े 1-2 वीडियो यहाँ पे मेरे पास में है, मैं उनको यहाँ पे दिखाना चाहूँगा थोड़ी देर बाद. सो ये करीब 2007 में, जनवरी 2007 का है. स्पेस रिकवरी एक्सपेरिमेंट था, कैप्सूल को रिकवर किया गया था समुद्र से. तो उसमें जो है 550 किलो का एक जो कैप्सूल है वो उसको जो है 637 किलोमीटर की ऑर्बिट में छोड़ा गया, और वहाँ से उसको फिर डीबूस्ट करके उसका मोटर को फायरिंग करके उसको वापस अर्थ की तरफ लाया गया, जिसमें 100 किलोमीटर के अंदर वो एंटर किया करीब, और 8 किलोमीटर पर सेकेंड उसकी करीब वेलोसिटी थी, जिससे जो एरोडायनेमिक हीटिंग होती है जो कि बहुत सीवियर होती है, उसमें 1500 डिग्री समझ लीजिए, 1477 डिग्री जो है उसमें हीट आती है, उससे उसको प्रोटेक्ट करने का उसका स्टडी किया गया. और उसके लिए जो मटेरियल थे वो कार्बन फिनोलिक, जो नोज़ कैप था वो यूज़ किया गया था, वो हमारे वहीं डेवलप किया गया. सिलिका टाइल्स उसके लिए जो ज़रूरत है उनकी वहीं डेवलप किया गया, और उनका परफॉर्मेंस स्टडी किया गया. तो ये एक बहुत बड़ा एक्सपेरिमेंट था उस टाइम पे. तो इसमें एक चीज़ और मैं कहना चाहूँगा कि जो शायद मैं वीडियो पहले दिखा लूँ तो अच्छा रहेगा. इसमें दाईं तरफ अगर आप देखते हैं तो उसका जो मिशन प्लानिंग है वो उसमें दिखाया हुआ है, आप देख सकते हैं. और ये जो ये है उसका जो वीडियो है, इसका ये डीबूस्ट शुरू हो गया है यहाँ पे. और डीबूस्ट मतलब उसका जो ऑर्बिट से अंदर लाने के लिए शुरू हो चुका है, अभी एंटर करने वाला है. ये देखिए उसका री एंट्री हो रहा है यहाँ पे. इसमें जो 1477 में बोल रहा था वो टेम्परेचर इसने देखा, और उसके बाद उसको पैराशूट के साथ उसको समुद्र में रिकवर कर लेते हैं. अभी ये रियल पिक्चर्स आ जाएंगी. यहाँ पे अभी वो समुद्र पे लैंड कर गया. ये रियल पिक्चर्स हैं जो उस मिशन की थी, और उसको फिर ये कि जो बॉय के सहारे या फ्लोटिंग सिस्टम के सहारे उसको ऊपर लेके जो है उसको कलेक्ट किया, फिर उसको स्टडी किया कि जो आपका जो बाहर का कवर था या थर्मल प्रोटेक्शन सिस्टम था वो कैसा काम किया है, और उसके अंदर जो एक्सपेरिमेंट भी कुछ रखे थे उनको भी निकाल के स्टडी किया गया. तो ये बहुत अच्छा परफॉर्मेंस हुआ था. इनफैक्ट ये पिक्चर राइट साइड में जो दिखाई है ये पहला स्पेस ऑब्जेक्ट था जो स्पेस में गया इंडिया से, और वो वापस आया और वो अच्छे से काम किया है उसने। और इसका बहुत बड़ा मीनिंग था उस समय से भी और अभी भी, क्योंकि इसको बाद में जो हमारा अभी क्रू मॉड्यूल है जो जिसमें एस्ट्रोनॉट बैठ के वापस आएंगे गगनयान में, वो भी ऐसे ही आने वाले हैं। तो उसके लिए एक और एक्सपेरिमेंट फिर बाद में किया गया 2014 में, जिसमें एक्चुअल क्रू मॉड्यूल जिसमें आदमी बैठ के जाएंगे और आएंगे, वो मॉड्यूल को जो है रिकवर किया गया। तो ये मिशन था, 19 मिनट इसको लिया गया और इसको 126 किलोमीटर की हाइट से जो है री एंट्री कराई गई वापस, और इसका वेट था 3.7 टन्स, जो कि पूरा सिमुलेटेड था जो एक्चुअल क्रू मॉड्यूल है। और इसको मैंने वीडियो नहीं डाला है क्योंकि वो बहुत सिमिलर दिखेगा, लेकिन आप इसमें अगर देखें तो रिकवरी उसका फ़ोटोज़ वगैरह दिखाया हुआ है यहाँ पे। ये एक्चुअल मॉड्यूल है जो सी से रिकवर किया 2014 में दिसंबर, और उसका ये जो पिक्चर है, तो इसमें भी सक्सेसफुल अच्छा मिशन रहा। तो इसके बेस पे हम कह सकते हैं कि री एंट्री विल बी ए गुड सक्सेस, विच इज़ एसेंशियल फॉर मैन्ड मिशंस। और एक और चीज़ होती है, जब आप मैन्ड मिशन छोड़ते हैं तो उसमें एक बहुत बड़ी समस्या रहती है कि अगर आपका लॉन्च कर दिया और उसके बाद आपको कुछ प्रॉब्लम दिखती है। वो बहुत बार हुआ भी है यूएस में, और यूएस में शायद हुआ था। तो उनको कम से कम जो एस्ट्रोनॉट हैं उनको उनकी ज़िंदगी सबसे ज़रूरी है, तो उनको बचाने के लिए कोई तरीका होना चाहिए। तो उसके लिए एक पैड अबॉर्ट टेस्ट किया गया। पैड अबॉर्ट टेस्ट भी अभी हाल में ही 2018 में किया गया, वो जुलाई में। तो उसका भी मेरे पास एक छोटा सा वीडियो है, मैं उसको जस्ट दिखाना चाहूँगा यहाँ पे। उसका मिशन ड्यूरेशन था सिर्फ 4 मिनट, क्योंकि इसको खाली ऐसी जगह से लाना था जहाँ से उसकी रिकवरी पॉसिबल है, जहाँ पे वो पैड अबॉर्ट होता है रियलिटी में जो या गगनयान में। तो उसको 4 मिनट और 25 सेकंड का जो मिशन था उसमें था 2.75 किलोमीटर से उसको पहले लॉन्च किया वहाँ तक, फिर उसके बाद उसको वापस लाए और उसको रिकवर किया, और उसका वेट था 12.6 टन। तो ये एक्सपेरिमेंट भी हुआ था। These are the actual video of the mission.
3, 2, 1.
So this is a solid state motor, actually a stage motor which is used for this, and it has taken to the height, required height.
Pitch mode recognition confirmed, performance normal.
And then you can see that at some point the pyro devices activate and the crew module separates from the defective vehicle, and then it comes down to earth with parachutes. And these parachutes open and then crew module is safely brought to the ocean so that their life is saved. So this happened to prove that our Gaganyaan mission, in case our rocket has an issue, because rocket is a very complex.
Deployed.
So you can see the parachutes are deployed here. And this is from the onboard camera on the module, which is taking picture of the parachutes or whatever activities are happening. So in case any issue comes, that can also be studied live there. So this was the one experiment which was done. So finally it landed safely, and that picture also was there. Anyway, that's not important.
Minus 30 minutes. 3, 2,
Sorry, I think
1.
I've gone on the loop. So this mission also gave a lot of confidence. And after this, today we have all the capability for Gaganyaan. But this is not the only thing, which are so many other activities which happened. These are few things which have come to major way, which are there. So just I thought I'll show here. And then another concept which I was talking, these are all for the Gaganyaan. I was talking about another concept. Today it is a very clumsy way of bringing back the humans. In a capsule, they are dumped into sea and then they have to be picked up. And Russia also, it happens, everywhere it happens like that only today. Russia basically they take it to the desert area. The capsule falls on the desert area and then they are recovered. China also does it similar way. In India we have a lot of ocean, so we are taking to the ocean and then recovering. But the best way would be to put them on a space, aircraft kind of thing, which lands on a runway. So that is the next plan, and that is where ISRO has been actively working, and first experiment has happened for that in 2016 itself in May, and here it was launched on a two-stage kind of prototype basically. It was not a real rocket. Two-stage means first stage is taking the space shuttle kind of thing up, and then it is re-entering and landing on the sea basically. First program was that, so that you know all the other controls, navigation, guidance, heat shield study, everything you can do on that mission. And here nose cap was carbon, and underside we have again our same old silica tiles which were developed for the RLB program were used here. And I am happy to say that this mission was a successful again. It was done, and some pictures may be there because I thought video will become very repetitive. I have avoided that. And anytime soon you will be hearing about the landing, actual landing on a runway. Runway is built now already, and RLV TD, the landing experiment, for which around 4 tons of mass of this particular craft will be taken to a height of 3 kilometers, and then it will be brought down in a controlled way with parachute. It will glide and navigate basically to a 3-kilometer runway. Slowly it will land there. So these two technologies together will give us our first space shuttle kind of thing, which will be more optimized than America's shuttle probably. So just few points are here in this. So this gives the mission planning of the RLV TD mission, which already has been completed, successfully. And here the different heat fluxes I have shown, what it is faces during the re-entry and what kind of materials we are using, which are all developed and used in the mission. So this knowledge is there today. And many other new technologies are there. For example, airframe engineering, which was not the cup of tea of ISRO so far. Only aircraft manufacturers have that. That came. And then propulsion systems, boosters, reaction control systems, actuation systems, thermal protection I just told about, and then communication with the satellite and control. So that was another major activity. And just one roadmap I have put here, which will be the real thing. And here one thing important, if you look at, we are talking about orbital mass of 17.2 tons in a low Earth orbit. So something like our International Space Station, if you have to put, man carries it there, puts it there, and then does some experiment and then comes back. That kind of vision is there. So this may happen at some point, but for this we are developing a semi-cryogenic engine there, ISRO, for which again many material activities are there, which I was also associated, including certain ignition resistance materials, because here you use liquid oxygen in a big way, and kerosene is used here, so that cost of booster comes down drastically. So this is one of the engine which will come, and this will give booster performance in the lower level. And it will be added with the solid 200-ton solid strap-ons combined with the cryogenic of higher capacity 32 tons in the upper stage to give this kind of capacity, and payload of around 11.2 tons, and balance will come back. So this is the vision, and it will land on a runway. So this roadmap is very correct for this kind of missions in that sense. So, and Gaganyaan also, I thought I'll just mention, so many technologies are required. I have shown few of them. So this is a simplified activity. Yeah. So now I'll come to another thing, very interesting area. I think I have got few slides. Gravity, everybody, all of us know which physics we have studied, but then microgravity happens in satellites, which is again of a lot of interest for researchers as well as the actual users. Exotic materials can be made, and then humans are exposed to actually microgravity when they are in space station for longer time. So what happens to them? Biological experiments, biological science. Then you have plants at one point probably will be settling in the planets at some point. It is going to happen. So what happens to plant growth or agricultural science? All these kind of studies, they are real today. They are already happening. In fact, other places it is already happening. And small time experiments are happening in your hyper loop kind of aircraft, basically that gives hyperbolic flight, that gives some few minutes of microgravity. Then there are sounding rockets which are available in this fleet of sounding rockets which are available in our Thumba itself, which are giving 1 to 6 minutes. So some studies can happen. And then space stations are built by China and USA. which give again almost infinite time, because there is circling around the earth and all the time microgravity is available. And in India's own way, I mean in a simple way, we have made one PS4 our the stage which was earlier wasted, उसको जो है अभी उसमें माइक्रोग्रेविटी के एक्सपेरिमेंट किए जा सकते हैं, और भी बहुत सारी चीज़ें हो सकती हैं, मैंने यहाँ पे लिस्ट की हुई हैं, और ये एक्सपेरिमेंट ऑलरेडी हो रहे हैं. अभी एमसेट इंडिया ने C-45 फ्लाइट में एक्सपेरिमेंट किया था, इसरो का अपना एक्सपेरिमेंट भी था, और उसमें आप हमारा इंस्टीट्यूट है इंडियन इंस्टीट्यूट ऑफ स्पेस साइंस स्पेस टेक्नोलॉजी, उनका भी एक एक्सपेरिमेंट उसमें था. तो ये एक नई बिगनिंग हो गई है PSLV का जो स्पेंड स्टेज है, जिसको हम यूटिलाइज़ कर ले रहे हैं. और थोड़ा सा स्पेस क्राफ्ट्स के बारे में मैं कुछ और था इसमें, शायद मैंने पहले बोल भी दिया है काफ़ी. तो ये 4 तरह का स्पेस क्राफ्ट्स है, जिसमें जो है जो अभी यूज होते हैं कम्युनिकेशन, नेविगेशन, रिमोट सेंसिंग एंड साइंस. सो दीज आर द मेन काइंड ऑफ स्पेस क्राफ्ट्स, and these are the orbits what I was talking, polar and geostationary what I was saying earlier. So both have their own advantages. Polar you can use for the observation, earth observation, even your mineral resources, water resources, crops, even spying. our आर्मी को ज़रूरत पड़ता है रिकनेसेंस का, तो एक सेटेलाइट हमारा था, तो उसको भी इसी कैटेगरी में लॉन्च किया गया था पहले. और जियो स्टेशनरी जो है वो अर्थ के रिस्पेक्ट में एक जगह फिक्स रहता है, तो उसका कम्युनिकेशन और बहुत सारे अदर दूसरे एप्लीकेशन हैं जो यहाँ पे लिस्टेड हैं. इसमें राइट साइड अगर आप देखेंगे तो बहुत आपको दिख जाएगा. लास्ट में 1-2 पॉइंट में मैं बोलना चाहता था इसमें. एक ये जो नैनो सैटेलाइट्स का कॉन्सेप्ट आ गया है अभी, तो मोबाइल्स जो हैं दे आर वेरी गुड फॉर दिस नैनो सैटेलाइट्स इवन. तो 3 मोबाइल बेच के ही बहुत सारा अर्थ ऑब्जर्वेशन डेटा और बहुत सारी चीज़ें की गई हैं पहले. और अपना जो कल लॉन्च हुआ है अपना PSLV का, उसमें इंडिया का पहला कॉमर्शियल नैनो सैटेलाइट गया है, गए हैं, जिसमें 2 हैं एक्चुअली, थाईबोल्ट 1, थाईबोल्ट 2. और वो जो है अभी हैम रेडियो वालों से उनका लिंक कर रहे हैं वो लोग, तो उसमें जो है इमरजेंसी जो मैसेजेस हैं वो ट्रांसफ़र हो सकते हैं, या फिर और धीरे धीरे अर्थ ऑब्जर्वेशन उसमें वो भी कर सकते हैं. तो काफ़ी उसकी इंपॉर्टेंस आ रही है. और जो नैनो सैटेलाइट है वो मून तक भी पहुंच गया है. इनफैक्ट अभी ये एक मिशन चल रहा है नासा का, आर्टेमिस 1, तो उसमें नैनो सैटेलाइट ने ये पिक्चर वहाँ से भेजा है मून सरफेस का. तो व्हाट आई एम ट्राइंग टू से इज नैनो सैटेलाइट्स आर द इन थिंग which are very critical and which are going to be very important for researchers, including the institute like MIT of eminence. So many things can be done. These are the 4 categories by the CubeSat or nano satellites. They are very small. And there's so many areas they can contribute, and basically they can improve science and technology because students can get hands-on experience. They can design the satellite and that can be launched. Such opportunities are available in India because piggyback it can go with the bigger satellite, and there are many new type of research can be done at a low risk and low cost. Accelerated innovation is possible because many people can contribute to the idea and attempt. It's a public basically involvement in this particular kind of satellites. So with this I'll conclude. These are the few points which I have noted. So I see many research institutes which can contribute in our multifaceted missions, including science missions and re-entry technologies I was mentioning again and again. So there are many things which are required and which can be done here, and some very solid way some research contributions can be done by research projects which ISRO announces actually through his website, which can be linked to the academics directly. Then JRF, SRF also are taken in for specific projects. Then there is a need of simulation labs, process modeling, small nano satellites I just mentioned, and our sounding rockets, fleet of them available, that experiments on them, and the PS4 orbiting platform, which is also available for experiments. Here I have not added anything exotic beyond space tourism or other planet settling and many things which are talked in a brainstorming sessions worldwide. So with this I'll conclude. Let the spirit of space exploration thrive. Thank you.
Let us have a huge round of applause, my dear friends. Sir, you are the real heroes. I remember a vachan from Gita, Karmanyevadhikaraste ma phaleshu kadachana. Because sir is working as a scientist, the person who is sitting somewhere in his research lab and he's doing his work. Whether his experiments or the work getting success, going to get a success or not. Definitely, hats off to your perseverance, sir. It's an inspiration for all of us. And being a mechanical engineer, from the mechanical background, the person who knows something about the materials, so it was a really feast for me, sir. Basically, you have taken us from the materials, the drivers to use the materials. You have taken us through the space vehicles which are there. You have taken the travel of materials which was covered from since 1982 to the current state, and what are the capabilities of Indian Space Research Organization, what are the current trends going on, or what will be the opportunities in coming days. So with this, again, thank you, sir, for your lecture. Next, we will have a presidential speech. So may I now request Honorable Dr. Karad, sir, to speak his mind on this occasion.
Friends, to be frank enough, I was traveling through space for almost 1 hour, trying to understand the wonderful words of wisdom, giving us the insight and understanding of the space mission of India, an organization like ISRO. पता नहीं, मैं तो खोज में था, आत्मा और मन की खोज. पता नहीं, I should not ask the question to Mr. Bhanu Pant. ये infinity and the hugeness of the universe, I don't know whether we can make some comment on this. But whenever I listen and understand, trying to understand this entire mechanism of universe, I say mechanism. I know that I have not that deep understanding. When I said mechanism, this is a mechanism. And as we know, we have been always commenting upon the Atma ki khoj, Satchit Anand ki khoj. And we have got the understanding of the metallurgical part of it, the different techniques which are being used and finally reaching a nano satellite. At least for me, I have heard for the first time. But when we talk about nano satellite, I don't know what way it will enlighten our human race, and finally where and how to reach and what place. I have a deep sense of satisfaction when I was listening to Mr. Bhanu Pant, who happens to be from Uttarakhand, जहाँ ज्ञान की आलंदी देहू से देवभूमि तक जाने का छोटा सा प्रयास हुआ. I think I felt Mr. तुझं नाव विसरलो, म्हातारपण आलंय ना, मिलिंद पांडे, मिलिंद पात्रे, the Vice Chancellor, let us join hands somewhere, because I have a deep feeling that we have been always talking about the Abdul Kalam Sahab ki yaad aati hai. We are trying to establish a space research center near that organization which is just opposite the Rajbagh campus. But we do not have a deeper understanding But because of the great person, a great human being, a great scientist like Abdul Kalam, I have a deep feeling that we should work. We have just established a unique prize and conferred the delete on one of the gentlemen in the name of Abdul Kalam Sahab. So I'm trying to network such great people. That's what my expectation is. Now friends, some of you may have some queries or questions. Only 3 to 4 questions. Please tell the name and specific question. And Mr. Bhanu Pratap or Bhanu Pant will try to give his own concept and idea. So please, any one of you? Yes? Oh, so many hands.
Hello. Good evening, sir. Myself, Dr. Shree Tukaram from School of Biology. I have 3 specific questions. First question is, what is your view upon the 3D printed metals, whether they will reduce the production cost of the satellite launching? That is the first question. Second question is, every country is ambitious.
Only one.
Sir, this is the...
Oh no. I am the headmaster. Please.
Yes, you asked about 3D printing. In fact, today in biological also implants are being made by 3D printing. In fact, I am at Kalyani Center here. They are also making implants, titanium-based implants for human body, and through additive manufacturing. It is having advantage, but then it cannot be for a product which is very large numbers. That's the only issue. So if it is specific use, yes, it is going to have big advantage in terms of material cost and material saving also. So I hope I have answered you.
Yes.
Yes, sir. My name is Professor Omkar Kolgud. I am from School of Mechanical Engineering. Just I wanted to ask you that you have done several experiments from 1982. So you have also got some success and failures. So how you have managed success as well as failures, and how leadership plays very important role in managing this success and failures?
All the credit goes to our elders there, because I was like 19 to 20 years old when I started my career. So I have been seeing giants in the organization, like of course Dr. Kalam name you have taken, and Vikram Sarabhai I have not met. I was not fortunate enough to meet him. He was no more when I joined. But then there were stalwarts, people like our Satish Dhawanji, Professor Satish Dhawan, and our own material director. Basically, he was the director of our center also, Dr. Brahm Prakash. He is also very well known. So the leadership was always there. Dr. Gupta was there, so S.C. Gupta. So he is the gentleman who has handled maximum number of failures, rocket failures. But then we used to see him sleeping in the guest house and fighting with the problems with the team. So that is how it was happening. Then you get tuned to that line, and any failure you have to look at the solution at that time.
Yes. Good evening, sir. I am a final year student, Rugved Arge. My question to you is on microgravity, which you mentioned. So going forward, as you had touched upon, that the GSLV Mark III will have the stage 2, which will be used in terms of microgravity. So how exactly are you planning, and what will be the ways to utilize that while we use reusable rockets?
No, it is not Mark III, it is PSLV program, second stage, which is already being used in fact. And how to involve basically is there are even experiments can be proposed to ISRO by the community, and around 6 months time will be available for the orbiting platform. And they will give you all the specification of power available and other controls that are there, and you have to tell your requirement. I mean, you have to jointly sit with them and work out a kind of experiment. So that is how it happens, and it is evolving basically. It is now possible.
Yes.
Good evening, sir. I am Rishikant, Assistant Professor Innovation Management, School of Management PG. Sir, I would like to know how management science influence the rocket science.
You are talking about the management?
Yes, sir.
Yeah, it
School
is
of
very
Management.
important question actually. I would like to answer this because initially I didn't understand management at all actually. I was in the lab, mostly working, melting, forging, rolling, heat treatment, welding, that was my life. But then as I grew in the channel, I knew that, there is something, called R&D management or research project management, which is very critical and very important. Basically, how ISRO manages basically this is, which I have seen over the years is, first of all, there is a sense of participation from the top man, whosoever is the top person there. Second thing is kind of reviews, which happen for any problem, any not even one problem actually, any development or any status, where we are and how we are going, where to correct, where to improve, that kind of discussion. So review is very strong in ISRO. That was one of the major thing. And then of course, as I told, simulation, modeling, etc. In that trials, you don't go jump to the big problem straight. So that all is decided by the top managers, which may not be from your field at all actually. They may be from totally different field. Suppose materials I am talking, but then the top man may be an electronics engineer. So like our Madhavan Nayarji was an electrical engineer basically, and then he used to guide us in all areas. So that is how the leadership. So leadership management is very important for all R&D missions and programs.
Yes.
Good afternoon, sir. I'm
Yeah.
Isha Talati from the electronics background. I'm currently a student, the member of MIT-WPU small satellite group. So my question to you is, you spoke on small satellites and nano satellites. So any guidance that you could give us to take this group to actual real life implementation ground?
My advice will be, since you are a student, my advice will be two things can be done. One is basically you can have interaction with the center itself, like we have got a URSC, our center in Bangalore. That should be possible because your faculty can straight away write. I can probably get some names and try to link them. You can go and visit and see the real things happening there and discuss the nano satellite what you have, or the small satellite what you have in mind or what you have been conceiving. And it is happening actually. It is with different institutes. So you must be seeing, in fact, before yesterday's launch, earlier the CEO of this company, he was some academic. I don't remember his name now. Dhruv is the company. So from academic, he came as a small satellite, launched in one of the PSLV or PSLVs, and then today he is launching a commercial satellite with his own company. 40 people are there in Hyderabad. So yesterday it happened. So what I am trying to say, have a connect. You should plan to visit. Even MTech students can go for their project works to different centers, which is possible. And even academic faculty can write to certain scientists there who are into the project, and then generate the plan for their own research project.
Thank you. I think I must make a mention of my esteemed friend sitting next to me, and Dr. Rahul Bhante Bodhi. To be frank enough, I always call philosopher Sant Dnyaneshwara as an embodiment of knowledge divine. Jesus Christ as an embodiment of love and compassion. Likewise, all the great saintly people who have understood this mechanism of the universe and the ultimate reality, the ultimate God, who may call Ram or Rahim. But here is an embodiment of Panchasheel. तथागत गौतम बुद्ध ने बात किया है, दुनिया को संदेश दिया है. We normally, let me tell you friends, that the world today or hereinafter also will continue to have a recognition of this Mother India in two names. One is Mahatma Gandhi and second is Tathagat Gautam Buddha. And Gautam Buddha has been in the search of knowledge divine. As I said to you, Dnyaneshwara, if it is said to be an embodiment of knowledge divine, and Tathagat Gautam Buddha as an embodiment of peace, love and compassion. तर म्हणजे भाषणच व्हायला पाहिजे. अचानक येणं झालं, कदाचित पुढच्या वेगळ्या वेळेला आपण वेगळं भाषण ठेवू, पण त्यांच्याकरता पंचशिलाचं साक्षात रूप आहे. मी कौतुक करत नाही, मी फार जवळून पाहिलं. तेव्हा आज दोन्ही पाहुण्यांच्याकरता आपण जोरदारपणे टाळ्या देऊन त्यांचं कौतुक करूया. चला.
Thank you, Honorable Dr. Karad sir. Thank you, Rahul sir, for your gracious presence. Let us, thanks my dear friends for being a part of this question and answer session. And once again, I'm thankful to Dr. Bhanupant sir for gracing this occasion. We, MIT-WPU family wishes you all the best for your future. May I now request Dr. Tapan Panda sir, Pro Vice Chancellor, MIT World Peace University, to propose vote of thanks.
Thank you. We are coming towards end of the day and end of the session, ladies and gentlemen. I would like to thank the audience first for their time, for being here in a Sunday afternoon and asking very interesting questions, particularly the students who are present here. Thank you, Dr. Vedant Rahul Bodhi Mahathero. This is my first experience to sit next to a Buddhistic scholar, and I was going through the long list of institutions that he has built over a period of time. I guess somebody has to live 2-3 lives to get involved into, which you have done in such a short period of time. Dr. Vishwanath Karad asked an interesting question as concluding remarks to Dr. Pant's statement that what science is going to do with evolution of human race, right? We understand the idea of science is to understand material and physical world and connect the relationship between materials and physical world. And the spiritual world is something that talks about human growth. And space is the element that connects science with the spiritual world, which is well represented by Dr. Pant. Let's give a big hand to Dr. Pant. I realize that Dr. Pant comes from a place which has one of the biggest and powerful telescopes of the world in Uttarakhand. We also now know that we have a big scientist also from Uttarakhand there. It was like my physics class. I graduated in physics before I came to business school. So it was like going through the physics class that I had in Ravenshaw College, where Dr. Pant talked about not only material engineering that he studied, but he talked about the evolution of space science and space research in India. We understand when countries started exploring space, the prime factor was probably in the classic science literature about knowledge, but later on it was about warfare, then it was about spying. India is the first country which wanted to use space technology and space science for the benefit and socio-economic development, which was well reflected in the first 2-3 slides of Dr. Pant, why ISRO was being created by Satish Dhawan. We also understood how the rocket technology and space science has evolved. As everything evolves from small material, then goes bigger, like a Big Bang theory then breaks down. Similarly, from a large PSLV satellite, we are moving into nano satellites, and you assume that the size of the mobile phone, it moves in the space, how much of information it can capture over a period of time. I'm pretty sure that in a Sunday afternoon, to many students, those who are present here, his conversation and deliberations have been very inspiring. Thank you, sir, for the scientific as well as the historical aspect of space technology that is in India. I am also thankful to my Vice Chancellor and Pro Vice Chancellor, Dr. Pandey, for organizing this. But before I conclude, I would like to conclude with a story. This story is about birds. So there was a Hindu temple and there are a lot of birds. You can see the birds here. Right, कबूतर, बहुत सारे कबूतर उधर थे. तो एक दिन रामनवमी की पूजा हुई, तो मंदिर में पेंटिंग हो रहा था. तो सबने पेंटिंग करना शुरू किया तो सारे कबूतर उड़ गए। तो फिर उन्होंने कहा कहाँ जाना है, तो ये कबूतर एक मस्क में गए। मस्क में पहले से कुछ कबूतर थे, लेकिन उन्होंने बोला ठीक है आ जाओ हमारे साथ रह जाओ। फिर कुछ दिन के बाद मुहर्रम आया तो मस्क भी पेंटिंग होने लग गया मस्जिद। फिर ये दोनों उड़ गए कहाँ रहना है, तो एक चर्च आया। तो जब चर्च में गए वहाँ भी कुछ चिड़िया थे, तो तीनों मिल के एक साथ रहने लग गए। फिर क्रिसमस का वक्त आया, फिर वहाँ भी पेंटिंग होने लग गया। तो तीनों जो कबूतर थे, एक मंदिर से, एक मस्जिद से और एक चर्च से, तीनों फिर मंदिर में वापस आ गए। तो अगले दिन जब वो वापस आए तो बाहर लड़ाई चल रही थी। तो एक छोटे से कबूतर एक बड़े से कबूतर से पूछा ये लड़ाई क्यों हो रही है। वो बोलते नहीं, ये हिंदू हैं और ये मुसलमान के खिलाफ लड़ रहे हैं और ये मुसलमान पत्थर मार रहे हैं। तो सारे कबूतरों ने बोला चलो मुसलमान की मस्जिद की तरफ चलते हैं, उधर भी लड़ाई थी। उसके बाद वो लोग भागे क्रिश्चियन की जो चर्च थी उस तरफ, उधर भी लड़ाई चल रही थी। तो छोटी सी कबूतर कंफ्यूज हो गया, और फिर वो पूछने लग गया ये इंसान लड़ते क्यों हैं। तो फिर उन्होंने बोला कि हम कबूतर हैं और ये इंसान है इसलिए वो लड़ते हैं। तो जितने सारे कबूतर थे वो ऐसे एक जगह ढूंढ रहे थे जहाँ पे हिंदू मुस्लिम क्रिश्चियन की जितने भी थॉट्स थे सबको एक साथ आना था। तो बिफोर आई कंक्लूड माई स्पीच, आई एम प्रेटी श्योर यू मस्ट हैव लुक्ड इनटू ऑल द पिक्चर्स which are on this wall, and thank you Dr. Karat for creating a temple where irrespective of whichever religion you are, what kind of bird you are, you will always find a place. Thank you ladies and gentlemen.
Thank you, Dr. Panda, sir. A beautiful story you have talked here. Now we are moving towards the end of the session, today's session. So before that, I would like to make the announcements for tomorrow's sessions. As usual, we are going to gather here for the yoga session at 7 a.m. sharp. Then after yoga session, we have a session at 8:45 a.m. Honorable Sri Sachin Parabji is going to guide on us, and his topic is भारताच्या जडणघडणीत महाराष्ट्रातील संतांचे योगदान. And after that, we have a session from Honorable Professor Nitin Banogde Patil, who is an inspirational speaker and history practitioner. And sir's topic is Yuga Pravartak Chhatrapati Shivaji Maharaj. So kindly note about this. So let us conclude today's session. Yeah, session in the evening is Dr. Vedabhyas Kundu, and sir's topic is non-violent communication for harmonious coexistence. So kindly note. So let us conclude today's session with Pasaidan. So I request to you all, kindly rise in your seats. Request to the technical team, kindly play Pasaidan.